All right, everyone. So just kind of a quick review of some basic concepts here. Determine the measures of the different angles. Well, since we have parallel lines here, and this line is a transversal, we have alternate interior angles. That means this is 39 degrees. Okay. Now, since this is 90 right here, okay, remember consecutive angles are supplementary. So these two make 180, those two make 180, which means this is 90 and this is 90. So if angle 2 is 39, 90 minus that is 51. And then angle 3 is going to be 90 degrees. So basically we have a rectangle or a square depending on the lengths of the sides, which we don't know. Okay, for the next one, again, we have parallel lines with transversal, so we have alternate interior angles here. So number 6 is 22 degrees. Okay. Now, remember, since these two are supplementary, 180 minus 125 means this angle here is 55 degrees total. Well, if angle 6 is 22, and we subtract, that means angle 5 is going to be 33. Now, opposite angles are equal, so this angle is going to be equal to this angle, which means it's also 55, minus 22 is 33. Or another way is, angle 5 and 4 are alternate interior angles, therefore they're equal. Okay, so just some core concept. I'm not going to read to you. You can read this, you can hit pause and move on. Okay, but these are your basic shapes of rhombus, rectangle, and square. All right, now the rhombus corollary. Okay, remember a corollary is a subset. So quadrilateral is a rhombus if and only if it has 4 equal sides. So based on what we just learned here, that a rhombus is a parallelogram with 4 equal sides, okay, that is the corollary. And then the rectangle, it has to have 4 90-degree angles. And the square corollary, which is based on the previous page, you have to have 4 right angles and all sides equal. In other words, it's a rhombus and a rectangle. It has the characteristics of both. It's a hybrid. It's like the rectangle and the rhombus got married, and there's your square. Okay, so for any rhombus, QRST, decide whether a statement's always or sometimes true. Well, what you want to do is just draw a rough rhombus. So I'm going to try to make this so it looks like these sides are all equal. Not the best job, but so there's a rhombus because they're all equal. We're going to label it QRST as we go around it. Now, with it being a rhombus, we also know that opposite, or parallelogram, opposite angles are equal. So being that a rhombus is a parallelogram and opposite angles are equal, Q and S are congruent. Therefore, this is true. And that means always true. Now, looking at the same drawing, is Q going to be equal to R? Well, in this case, no. You can tell that Q and R are different angles. One's obtuse, one's acute. So, in this case, you might say no. But our only choices are true, always true, and sometimes true. So when would it be true? Well, if we had a hybrid situation where we had a square. Because it's a rhombus, all equal sides, Q and R are both 90 degrees. So when it's a square, then it's going to be sometimes true. But it's only in that certain circumstance when it's a square, not just a regular rhombus. Okay, what's going on here? Well, right off the bat, we look at this and we know this is 70, the opposites are equal. And since consecutives are supplementary, we have 110 here. That all adds up to 360. These two add up to 180, these two add up to 180, 180, 180, just like it needs to be. Well, given that we have no 90-degree angles, it's not a square because there's no right angles. But since we have 4 equal sides, it is a rhombus. So 4 congruent sides, but no right angles. Okay, some theorems. The Rhombus Diagonal Theorem is a very important one. When you have the diagonals intersect, they intersect at a 90-degree angle. And it's going to come into play here in a little bit. And again, you can stop and read this if you want, and more in depth. Rhombus Opposite Angles Theorem. A parallelogram is a rhombus if and only if each diagonal bisects the pair of opposite angles. So notice at A, it is split into 2 equal angles, and at C, it's split into 2 equal angles. And at D and B, they're split into 2 equal angles. All right, so, wow, what's going on here? Lots of stuff. So let's see what we can figure out here. First off, we know that since this is a rhombus, we know this angle right here is the intersection of the 2 diagonals. So angle 1 is 90 degrees. Has to be. All right? Now, since it's a rhombus, it's also a parallelogram. Okay? And the diagonals are transversals, which means we have alternate interior angles. So angle 2 is going to be 61 degrees because of the alternate interior angles. Now, we also know that the diagonals bisect each angle. So if 2 is 61, that makes 3 also 61. And then, what do 1, 3, and 4 form? 1, 3, and 4 form a triangle, which means they add up to 180 degrees. So if we do 61 plus 61, we get 122. Which doesn't help us at all. That's just plain silliness right there. We're not adding 61 and 61. Let's see how many of you caught me on that one. Angle 1 is 90 plus 61, which equals 151. Now if we subtract that from 180, that gives us angle 4 being 29 degrees. Okay, new theorem. The diagonals in a rectangle are congruent. Okay? They are congruent. They also, as you can tell, they bisect each other. So, we talked about that before. They are congruent and they bisect each other. And so in a rectangle, every little piece equals each other. Alright, so we're almost done here. You're building a window frame. Is this a rectangle? Is this shape right here a rectangle? Well, let's see. It does have opposite sides equal, which is very important for a rectangle. Okay. So, opposite sides are congruent, but we don't know the angles. So we cannot assume right angle or rectangle. Okay? And honestly, it may look like they're 90 degrees, but it could be 90.1 and 89.9. Or 90.5, are 91 and 89. And in the real world, if you actually go and measure a lot of openings in houses or corners in houses that look 90 degrees, they may be 89 or 88. Okay. Now, you measure the diagonals of the openings. One diagonal is 54.8, one is 55.3. What can you conclude? Okay. Well, diagonals must be congruent in a rectangle, so also we can say right now it's not a rectangle because the diagonals are not congruent. All right, and we're almost getting there. So right here, in a rectangle, QRST, okay, we have QS and RT, which are diagonals. Find the lengths. Well, if they are truly diagonals of a rectangle, they are equal to each other. If they're equal to each other, we just solve. Subtract 2x, add 31. X is 14. Plug 14 into either one or both. I'm going to do 2 times 14 plus 11. Okay? And that's going to give me 39. So both diagonals are 39. And last but not least, here we go. So we could graph this on graph paper to get a better idea, but I'm just going to roughly sketch this. Okay? So I'm going to say negative 2, 6 is right here. 6, 8 is right here. 4, 0 right here. And negative 4, negative 2 out here. And this is just a very rough sketch. Pretty horribly done. But if you saw on graph paper, you could see there doesn't look like they're 90-degree angles. But we can still prove that. Now, if this is on graph paper, you could just find the slopes by literally counting like that. If they're not on graph paper, you have to do y minus y over x minus x. So first off, let's prove it's not a square. So the slope of AB, okay, is going to be y minus y, so 8 minus 6 over 6 minus negative 2. Which is going to be 2 over 8 or 1/4. Okay, now the slope of BC, and I'm just picking two intersecting lines to prove that they don't intersect 90 degrees. If they were 90, this would have to be negative 4, right? Negative 4 over 1, opposite reciprocal. Let's see what it ends up being. So I'm going to do 8 minus 0 over 6 minus 4. That's going to give me 8 over 2, which is 4 over 1 positive. So not a right angle. So not a square. Now, next, let's test to see if it's a rectangle. If it's a rectangle, diagonals are going to be congruent. That was supposed to be green. It's still supposed to be green. This and this should be congruent. They don't look congruent, but let's prove it. So I'm going to do the distance formula for AC. So negative 2 minus 4 squared plus 6 minus 0 squared. And I'm not going to worry about decimals. I get the square root of 72. Okay, 6 squared and 6 squared, 36, 36, 72. Now I'm going to do BD. Now I'm going to do 6 minus negative 4, which is going to be, 10 squared is 100. And then I'm going to do 8 minus negative 2, which is also going to be 10 squared is 100. So that's the square root of 200. Well, the diagonals are not equal, are they? So not a rectangle. So last but not least, we need to prove it is a rhombus. Now we have two choices for that. The longer way would be to do the distance formula for all four sides. Okay? But the shorter way is just to prove that the diagonals are perpendicular. That's quicker. So we need to just find the slope of AC and the slope of BD. So AC is going to be 6 minus 0 over negative 2 minus 4. Well, that's going to be 6 over negative 6, which equals negative 1. So if this is positive 1, we're good to go. So BD is going to be 8 minus negative 2 over 6 minus negative 4, which gives us 10 over 10, positive 1. We have perpendicular diagonals, so it is a rhombus for the win. And that's it.